I remember 3-4 years ago, I asked two different people who were the people to follow about BIM in the world, and everybody told me that the person that I would have to follow was DominicThasarathar. So it was in my mind to have him during these 2 last years. And finally, we are fortunate to have him here in Barcelona. Hoy estamos de suerte y la sesión inaugural.
We are lucky because the opening session will be in charge of the worldwide BIM thinkers, who is DominicThasarathar, and I want to thank him for being here with us today. Dominic, I give you the floor.
Good morning, and thank you for taking the time to join us today. Thank you for the kind words of introduction. Unfortunately, I'm not actually going to talk about BIM today. But before you start throwing things at the stage, I'll explain. I'm DominicThasarathar. At Autodesk, I'm responsible for what we call thought leadership for the construction, energy, and natural resources sectors, which means I'm in the incredibly fascinating but often quite frustrating business of trying to predict the future. Specifically, how we see trends in technology are going to change the way in which the world's buildings and infrastructure are planned, funded, designed, built, operated, and indeed maintained. And it's that future that I've been asked to spend about 30 minutes sharing some observations with you on, really from two perspectives. What are we seeing as the next wave of technology trends that are going to take your industry beyond the building information modelling that you've all been doing a good job of practicing over the last few years? And secondly, how are companies around the world, in the architecture, in the engineering and in the construction space, thinking about and beginning to respond to those trends? So before I begin, I do have to offer the health warning. Predicting the future is never an easy business. I can and frequently do get it wrong. Thankfully, I still get paid. But as we go through this, I'd like you to think in terms of possibilities, probabilities, and opportunities rather than absolutes. But above all, perhaps ask yourself those big existential questions of what if? What might these mean to the way that my company operates, its competitive position? What might it mean for me as an individual in the AEC industry? Okay, let's start. Why is it important to think about the future of the world's buildings and infrastructure? Well, here are 3 very good reasons. We know over the next 20 years, population growth, urbanisation, economic expansion are going to underwrite an insatiable demand for more buildings and infrastructure. A lot more. Just by 2030 alone, we know the market for construction output will increase by 85% in real terms, pushing the market up to around a $17 trillion market. And that's great news for everybody here in this room. There's more work available. But this is important point is it's not more of the same. Already today, our built environment consumes 40% of the world's energy, produces 40% of the world's carbon dioxide emissions, and consumes 30% of the world's natural resources. And that is simply unsustainable. So your industry is going to be tasked with coming up with new solutions to old problems and indeed new solutions to new problems in solving this challenge of creating enough buildings and infrastructure for the world, but doing it in a way that doesn't impact the planet. But there's another factor as well in these graphs. It's the fact that the market for provision of architecture, engineering and construction services is becoming increasingly globalized. So just as there is more work out there, there will be more competition. And you will be relied upon to steer your companies about how you should compete in those markets going forwards. Well, for us at Autodesk, we're really excited about the future because we think technology is going to help you answer the challenges that are enshrined in these graphs. So let's talk about technology and how technology can change the way in which buildings and infrastructure are made and indeed change the market for provision of AEC services. I'm going to jump back 2,000 years and show you this building. It's probably familiar to many of you here, if not all. This is the Pantheon in the eternal city of Rome. It was built around 2,000 years ago, the 2nd century AD, and it's a fantastic example of building design. As my boss Phil Bernstein likes to point out, who is an architect, those of you with a keen eye may notice the early design mistake here. These square columns don't quite reach the ceiling as the round columns at the front do. Clearly a Roman contractor made a killing on a design change when they created this building. But for me as a former contractor, the really exciting thing about this building isn't what's on the outside, it's what's on the inside. This today is still the world's largest unreinforced solid concrete dome. There's a single piece of rebar in this. It weighs around 4,000 to 5,000 tons. It's 40 meters in diameter. And this was made possible by the technological innovation of a Roman contractor who created a new form of lightweight concrete containing volcanic ash that allowed them to span this sort of this very large diameter. And I think what it underlines for me is that technology has always disrupted the way in which your industry both plans, designs, and indeed creates capital assets. Looking forwards, we see a whole range of new technology trends starting to emerge. Everything from 3D printing to drones, from reality capture to cloud computing, all of which will have an impact on your industry. But for me, the bigger question is, what's going to be the combined effect of all of these trends that are happening? And at Autodesk, we've started to give this quite a lot of thought. And we're seeing a number of these trends are beginning to collide to cause 3 major disruptions in your industry. Changes in the means of production. So how project teams undertake both intellectual production, the design process, the formulation of commercial strategies, the creation of new business models, and how they actually undertake physical production. So going from a design for a building or a bridge or an oil refinery and turning that into a finished real-world physical asset. Both of those are going to be disrupted by technology. The second disruption we're seeing is this changes in the nature of demand. What's driving demand for output in your industry, for buildings and infrastructure? And indeed, what is shaping the nature of those buildings and infrastructure assets we're seeing is being changed by technology. And then finally, products. We know that things are getting smarter. We've all heard of the smart television, the smartphone, increasingly the smart refrigerator that automatically orders milk for you before you've run out. These things are getting connected. And with that connection, intelligence is starting to grow and it is moving out into the network. And that's creating new opportunities for you to add value to your clients' projects. So let's explore these in a little bit more detail. First of all, changes in the means of production. If we think about intellectual production, the design process, we're starting to see cloud computing is beginning to radically change the way in which you undertake design. The traditional design process has been limited by the amount of computing horsepower you have access to. Undertaking something like what you see in the top right there, simulation of wind flow through a complex urban environment, could have taken you quite some time to do in a traditional desktop environment. You may have been able to put perhaps 4 processors and a lot of memory inside one box and run a simulation like this. But today, the cloud is starting to allow you to access huge amounts of processing power on demand without having the expense of owning the associated hardware. That's opening the door to allow you to rent hundreds, if not thousands, of CPUs to undertake parallel processing. And that shifts the way in which design is done from today's quite iterative process, where you undertake a design, you analyze that design, you don't really like the results, and you go back and you redesign and reanalyze. You go through that loop as many times as you have time, money, and resources to throw at a challenge. Well, now, today, we're on this cusp of being able to completely sidestep that law because you potentially have access to an unlimited amount of computer horsepower. And that will shift today's design paradigm beyond iterative towards inline. And you see an early experimental example of that here in the bottom right. This is an example of a real estate developer who has determined that there is an opportunity for so many thousand square metres, perhaps of residential or office space in a particular urban environment. The question is, what should that look like? Is it 2 buildings? Is it 3 buildings? How many floors should those buildings have? What size should the floor plates be, etc.? To go through the traditional process of analysing all of those permutations and end up with the best life cycle cost has simply been too prohibitive. But going forward with an unlimited amount of computing horsepower, you are now opening the door to land on the best answer every time, first time. Take it a step forward. Are human beings the best to do design? This is an example of generative design, where a smart algorithm is harnessing that computing horsepower and running through all the different permutations to come up with the best answer to a design challenge. In this case, a set of outputs around what's the best compromise for spatial layout when doing building design. Can you imagine using this type of approach of generative design to tackle everything from traditional building design through to formulation of commercial strategies? This is another example of generative design, in this case of a chair, a very elegant chair. There's no way that I could have designed something like this, even given 100 years. And you can see that it's gone through a number of permutations, given those output parameters of strength requirements, cost to manufacture, weight, performance, etc. And it's then been 3D printed. Why is this chair so important? How is this relevant to your industry? Because when I showed this to a utilities executive, he talked about this. He talked about the challenges that they face, in this case in North America, of system outages. Wind loading, ice loading in the winter causes high voltage transmission circuits sometimes to collapse. And when they collapse, they can no longer transmit electricity and they get hit with fines. But it's a very fine balance between how much money you should spend to improve and secure the resilience of a transmission circuit versus the probability of that transmission circuit failing. There are so many permutations that need to be crunched. But going forwards, if you have access to that huge amounts of computing horsepower and smart algorithms, it should allow you to land on the best answer first time, every time. So how else do we see technology is going to change the way in which you undertake design? Well, we're seeing this real collision of the digital and the physical worlds. And that's causing 3 effects. The first is this ability to capture the real world and bring it into a silicon environment. Many of you are familiar with this type of technology. Laser scanning, creation of point clouds. We know that the fidelity of this type of technology is increasing all the time, and the cost and the ease of undertaking these types of surveys is falling all the time. But it's not the only technology that's out there. Advances in technology are now bringing us things like this. This gentleman is working for a North American utility, and he is using a cheap digital camera, the kind you will find on your smartphone, to take pictures inside this underground cable vault. He is then uploading those pictures to a cloud-based service that is using that huge amounts of computing horsepower to automatically create a dimensionally accurate 3D model of that cable vault. Which would you rather send your operatives into a hazardous environment with? A set of 2D plans, a basic 3D model, or something like this? And if you think this is restricted to the small scale, of course, we're already seeing applications at a much grander scale. This is an example from Rio Tinto, one of their borax mines in North America, where one of those cheap cameras has been fitted to a drone and it's flown over this particular mine. This mine has a lot of automation. It uses autonomous haul trucks to shift the ore from the bottom of the mine to the processing facility. But haul trucks are dependent on the qualities of the roads that they travel on. And that still means a traditional process of sending surveyors out into quite hazardous environments to survey those roads. Using this type of technology, they can get a dimensionally accurate model of the mine multiple times to see the conditions of those roads. The impact improves safety, less lost production time. So if that's how we're getting things into a silicon environment, what about getting them back out of the silicon environment? Augmented reality, we know, has been a promise for many years, but it's certainly now beginning to get far more interest and traction. Being able to take that fantastic design that you have done, that design that is right first time, every time, and project it back into the real world is starting to open up new possibilities. The possibilities are in the building sector, possibilities are particularly attractive in the utilities sector, where there is a lot of buried infrastructure. Imagine using something like this kind of technology in combination with remote sensing tools, like ground penetrating radar, to be able to ascertain actually what is underneath the ground, so that when you send somebody out to maintain that particular high voltage circuit, they're not going to put the bit of a digger through that circuit rather than knowing exactly where it is. There's a real interesting development we're seeing, particularly in the energy sector, around the use of augmented technology. And it is this challenge of the skills crisis. And we know that your industry in particular faces a challenge of really having to put old heads on young shoulders quite quickly. There is the need to get a lot of people up to speed. And this is probably been most keenly felt in the energy sector, in the oil and gas industry. And what that's starting to drive is the use of augmented technology as a learning tool. Combining augmented technology like this with cloud computing to provide real-time learning environments. We know as human beings, we learn by making mistakes. Learning by making mistakes is far more intuitive and it's far more effective than traditional rote learning. But making mistakes in the real world can be quite costly and it can be quite hazardous. Far better to learn in an immersive type of environment like this and come up to speed quickly, where you can play in the real world but do it safely because you're in a silicon environment before committing to being let loose in a production environment. So if we're capturing the real world at one end and we're pushing the real world out at the other end, the third thing that we're seeing, which is probably the most exciting, is what's happening in between those two stages. And it's the rise of the use of gaming engines, which has been a real crossover from the media and entertainment sector. Increasingly, gaming engines are being used not just to simulate geometry, X, Y, Z coordinates, but to simulate physics, to simulate crowd behavior, to simulate weather. We are reaching a stage where potentially it will be possible to simulate anything that you would commit to doing in the physical world beforehand in a silicon environment. And you're seeing here some examples. This one in the top left-hand corner is simulating evacuation of an offshore oil platform. Each of those yellow bricks is a real person with hopes and dreams and aspirations. How will they behave when the alarm sounds and they need to head to the lifeboat station? Equally, at a much grander scale, what you're seeing there at the top right is simulation of putting in a new capacity for an existing metro line. If you put a station at a particular urban neighbourhood in a downtown intersection, what is the impact going to be on the footfall of individuals at the retail outlets? Where are the choke points going to be? Economically, what is the...
¿Cuál sería el impacto, por ejemplo, de poner una nueva línea de metro, ¿no? Y podemos hacer una serie de reflexiones en torno a estas preguntas, porque podemos ver la realidad.
And the question that opens for you is, as our urban environments become far more complex, as we start to need to think not just in terms of individual systems, like a metro system, like a sewage system, but we need to start thinking in terms of systems, the interrelationship between those. We're excited about the potential for this type of gaming technology to help you answer those very big questions. A traditional question might have been, should I upgrade a metro system to increase capacity between two parts of a city? Today, a question might be, how can I stimulate increased economic growth in those two city locations? Part of the answer might be a metro line. Part of the answer might be building hubs at the stations along each of the stations along that metro line as business hubs. Increasingly, we expect companies to start to turn to this type of technology to help them chew up those answers. So let's change gears and talk about physical production now. Everybody in this room has probably seen this very famous video that came from China, from the Broad Group. This is the erection of a 30-story hotel in 15 days through the intensive use of prefabrication. Prefabrication has, of course, been with us for many years. What's new is the role that digital technology is beginning to play to really accelerate the prefabrication process. And going forwards, we are almost certainly going to see a huge commoditization of a lot of buildings and infrastructure. And that will have significant implications for the competitive landscape for many of you in this room. Will people be buying buildings like this from China and having them shipped flat pack, IKEA style, around the world and then just assembled on sites? The likelihood is that they almost certainly will. So if prefabrication is getting better and faster, probably the other area in which we know that manufacturing is changing because of digital technology will have an even greater significance for your sector. It is this rise of digital fabrication. Additive manufacturing, subtractive manufacturing, robotic, probably most famously known as 3D printing. 3D printing really holds the promise of radically changing the manufacturing process. If you think about the way that manufacturing has been geared up for the last 100, 150 years, it's been cheaper to buy an off-the-shelf product, component, than it has to have a bespoke one made. Economies of scale, huge production lines geared up to produce a lot of the same thing. That's because complexity and uniqueness are expensive traits in manufacturing. But now going forwards, 3D printing holds the promise of going directly from a fantastic design in a digital environment to a finished, real-world physical asset in a single touch, in a single machine, without having to retool. It's early days for your industry, but of course there are already some great leading experimental examples. This is a project that's happening in the Netherlands, MX3D, which we are one of a number of sponsors, which is 3D printing a steel bridge. And similarly, there are other examples beginning to crop up around the world. In this case, this gentleman in China is 3D printing whole buildings, available for around $5,000. But moving beyond the actual technology itself, there's actually a bigger disruption that's hidden here. And it's encapsulated in this picture. This is a microfactory. Microfactories are now beginning to emerge in many parts of the US. What's a microfactory? A microfactory is essentially a community hub where anybody can come along and print essentially anything or manufacturing anything through the use of digital fabrication technology. Why is this so important for your industry? It's so important because it holds the promise of collapsing supply chains. You think about the traditional supply chains you've had in your industry. They are quite long and they are quite restrictive. Can you see a future where perhaps the components that you need for your projects are manufactured locally to that project location? Perhaps indeed involving the end users of those projects. So let's talk about changes in the nature of demand. How do we think technology is going to change the demand for AEC services and indeed change the assets that are being built? Well, we've all seen the reports. We know that 2/3 of the world's construction output is going to shift towards one of today's emerging markets, certainly within the next 10 to 15 years. And we know that the majority of people are going to be living in quite complex urban environments. But what are the implications for that for you? Where should you be playing? What services should you be offering? What will your competitors be like? Increasingly, that's driving the use of these types of tools. Tools that allow you to analyze large amounts of data and represent them in quite graphical ways. In this case, this happens to be the city of San Francisco, where you can look at the energy requirements across a whole city. And if you were, say, an EPC contractor in the energy sector, you could help work with your clients making those decisions around should they be investing in one large cogeneration station, perhaps out by the edge of the bay, Or should they be supporting more use of rooftop solar, very democratic generation of electricity? Increasingly, the answer is going to be in the data, or rather in the big data, and we're expecting to see far more use of this type of tool to help organisations like yours make those decisions about where they should be playing and what types of offerings that they can bring to their end clients. Let's zoom down to the small scale now. That's the big scale. This is our PR manager. And he is sitting over on the east coast of the States, eating his very healthy breakfast, and he is looking at your project. Because today, the internet puts your project in the living room, in the bathroom, in the bedroom of everybody. Social and mobile computing means everybody has their say about everything today. And that brings some interesting opportunities for you. Accelerating the consultation process for major projects is something we're already beginning to see examples of in North America through the use of social computing. If you're going to run a major highway project through somebody's downtown area, is it better to engage them through a traditional community-based approach, or is it better to engage them through this type of approach? Move it beyond that. Who is the best person that's got the best answer for what that project should look like and how it should function? Do they actually exist within your project ecosystem, or should you be tapping into that greater community to help you answer that? Well, tapping into that increasingly is going to become important for you. We know that the world's governments are increasingly challenged to be those providers of social and economic infrastructure. Many governments are carrying large amounts of sovereign debt, and that really puts restrictions on how much they're able to spend to build the buildings and infrastructure that we need in our increasingly complex environments. This is an example of a new type of project from the Netherlands on just this point. It's a pretty simple project. It's a piece of social infrastructure. What you see there in colour, some elevated walkways, some landscaping. Of itself, it's not a particularly large or obviously significant project. But the reason why this project is so important is it's an example of a crowd-funded project. Here, the funding for this project came from the individuals that are going to use the facilities at the end of the day. And what that offers to you is a new era of localism, an era where you are far more tightly coupled with the end users of buildings and infrastructure assets than perhaps you've traditionally been. So finally, I wanted to touch on this changing nature of products, the fact that things are getting smarter. We've all heard of the smart home. Increasingly, we're hearing of the smart highway. You're driving along, there's a traffic jam, your car talks to the road that talks to your home, that ensures that the heating system is delayed by 30 minutes so that you don't waste the gas heating your house. We're also seeing this huge tumbling in price of sensors. Sensors are now at such a low price point that essentially, as in the case of this example, they can be scattered into the concrete of buildings. They can generate their own electricity through the natural vibrations of structures, and they can transmit data, increasing amounts of data. We know Cisco estimates by 2020 there will be 50 billion devices connected to this Internet of Things, and that number will grow by about 10 billion a year thereafter. The question is, what will happen and what can be done once you start analysing this data and connecting things together? Well, increasingly, it's going to close the gap between how much capacity you think you need to install and how much capacity you actually need to install, whether that's in office space, in heating capacity, in throughput for an oil refinery, in electricity generation. And what that should start to do is to drive up the efficiency with which we use the planet's resources and the efficiency of business. There is one final byproduct to this Internet of Things that has a particular resonance for the construction industry. If you can start to get hold of large amounts of data around asset performance, down to the micro level, so you know the mean time to failure for everything from a pump to a building, and you combine that with shifting demographic data, you combine that with economic data, what that should start to do is to allow you to better predict your project pipeline. If you can see that people are moving into a particular city location before the trend becomes obvious, and that they are moving into that city location because they like to live in high-rise apartment blocks. You can be sure that if you want to compete in that city, you're going to have to make a move towards construction of high-rise apartment blocks. And what we're hoping is this will give greater certainty of project pipelines for industry participants going forwards. So 3 disruptions: changes in the means of production, changes in the nature of demand, and changes in products, being driven by that myriad of new technology trends. What's the net effect of all of this going to be? Well, quite simply this: we think your industry's relationship with the built environment is going to change. It's going to change radically. Why? Because those 3 disruptions are creating a new competitive landscape for your industry. Going forwards, any company, regardless of size, regardless of location, regardless of capitalisation, regardless of the market they operate in, will have access to 4 capabilities. Unlimited amounts of processing power, on demand, without the overhead of owning that infrastructure, to be able to solve the most complex challenges effortlessly, in line with their business. The ability to bring together talent across geographies, across business interfaces, into the crowd, to get the best ideas. Anybody will be able to collide the digital and the physical worlds, bringing the outside world into a silicon environment, taking that silicon environment, gaming it, and then pushing that design out back into the real world. And then closing that gap in the real world by reducing the number of steps on the physical construction of buildings and infrastructure. And the net effect of that's going to be a freer flow of capital. For so many years, the construction industry has been defined as a project-based industry where 50% of projects exceed their budget, blow their schedule. Now, through the use of these types of trends, we're seeing predictability on construction projects will radically improve. Improved outcomes means investors are less wary. We're expecting to see freer flow of money into the industry for financing the world's buildings and infrastructure, and at the same time, the rise of alternative sources of funding like crowdfunding. Your industry has been through major disruptions already that have been led by technology. We had the invention of CAD 30 plus years ago, which led to what we roughly describe as the era of documentation. So you automated an existing manual process of drafting. We're kind of right now in this second era, this era of optimization, the use of 3D, 4D, 5D models to help you optimize individual project outcomes. So BIM. Going forwards, we're seeing a new era. We're calling it the era of connection, and we ourselves are still trying to work out the implications of it. But we think it's going to offer a significant step change for your industry in helping you respond to that future demand of more buildings, more infrastructure, and a changing competitive landscape. And the great hope is that we hope it transforms your industry from being a relatively high-risk undertaking to being a low-risk undertaking with certainly an increased margin. Thank you very much for your time.